So I'm going to be going over sort of the more internals of sharding and how it actually is working under the covers as opposed to how to use it in your applications. And O'Reilly just put out an ebook I wrote on how to do it in your applications. So this is sort of slightly different than the ebook, and if you're interested in a more practical approach, I'd suggest checking out the ebook. So this isn't like an introductory talk. I'm assuming that you already know what documents are, what a collection is, what a database is, and that the Mongo server is run using MongoDB. If you aren't familiar with Mongo yet, I'd recommend O'Reilly did a great webcast with Mike Dieroff on Introduction to MongoDB, and you should check that out first, or look up mongodb.org and try it out. So this is assuming that you have a basic foundation and know what MongoDB is. So getting started, I'm just going to review the important points of sharding so that we're all on the same page. So if you have an application, you're going to set up your Mongo, and you have a single Mongo server. Basically, you might have a replica set, or but basically you have a complete copy of your data on each of these machines, and you can access that data like it was on a single machine. And the point of sharding is to split out that data so that each shard has a subset of the data. And each shard might consist of multiple machines with a particular subset of your data, but no machine has all of your data on it. So this works well for when you have too much data. This lets you fit more data in RAM because you've got more machines of RAM to work with. It lets you get more inserts or writes or reads per second. And so basically it's just Mongo's way of scaling out across multiple machines. And so that's basically what sharding is. And the goal of sharding is to make this completely invisible to the user, so that when you actually access this cluster, you think that it's just a single machine, and your application doesn't have any idea that it has to be talking to multiple machines. And the way that Mongo does this is through using this routing process, which we call MongoS. And MongoS is basically, it doesn't hold any information permanently. It doesn't really do anything persistently, routing things from you to the correct shard or shards. So it takes care of routing reads. If you do read, it will be sent off to the right shard by the MongoS, and then the reply will be sent back. Same with writes. It will send a write to the right shard or shards. And then the interesting thing it does also is it keeps your data balanced. And so this is part of the whole sharding as invisible thing. Not only should your application not really have to know that your cluster is sharded, but Mongo should take care of keeping your cluster all balanced. So it continues functioning properly. And when you need more capacity, you can add more servers, but Mongo will take care of distributing the data for you. So if one server gets out of balance, MongoDB will gradually move the data off to the other shards and gradually rebalance it for you. It'll also handle failover. So if parts of a shard fail, it will automatically pick up on whatever is still up. If you're using a replica set, it'll be like, okay, the new master is whoever, and switch over to that. So let's take an example collection. Say it's like a collection of user profiles, and we have this collection on a single server, and we want to distribute it across multiple servers. So you don't have to read this, don't worry, but it's just representing this is our collection. We've got like a bunch of documents in our collection, and each one is like a user object. And so we've got this on our one server to start out with, and the goal is to get it, spread it out, divide it into chunks. Sorry, my thing just sort of refreshed. Okay. I'm going to assume we're still good. So what we want Mongo to do is divide up this data as... Okay, great. Thanks. So we want to spread out this data across all of the servers we've got. So Mongo doesn't do this on a per document basis because that would be like a ton of overhead to do this for every document. So it divides it into these range-based chunks, and then it moves documents in a unit of a chunk. And each chunk is 64 megabytes. It, up until very recently, is 200 megabytes, but 64 megabytes. And so 64 megabytes of documents can be moved from one shard to another to rebalance the cluster, basically. So say that our document looks like this. To split things into chunks, we need to just choose a field to use for ranges. And the field will take the values of the documents have for whatever field we choose and use those values to create the ranges for the chunks. So say we take the name field, and that's called our shard key. And so sharding is really flexible, and it works for a bunch of different applications because you choose a shard key or keys based on how your application is going to work. And this is kind of a difficult decision because choosing a good shard key is incredibly important to making your application work well. But nearly any application can work well given the correct shard key, but choosing the wrong shard key can have disastrous effects on your application. So it's like a really important decision, and unfortunately not one that Mongo can make for you. So this is sort of the one part of setting up sharding where you have to be aware that you are sharding. This is a distributed system. You have to be very careful and figure out kind of your usage patterns to choose. Also, like on the MongoDB website, on how to choose a good shard key. So we've got our collection of documents, and to turn these into chunks, we're just going to take a subset of the documents, say like names A through F for one chunk, and then G through M for the next chunk, and N through T, and then say U through Z. And so these chunks will have these ranges associated with them. And so if we're starting out with them all in one shard, and then we add another shard, this is where the balancer comes into play. And the balancer is basically this process that pops up every once in a while. We'll get into it a little later, but it pops up every once in a while, and it's like, hey, you have more chunks on this shard. Let me move some over. And so it'll start migrating chunks over, and we'll get into how a little later too, until the shards have an even amount of data. And notice here that each shard can contain multiple non-contiguous ranges. So we've got like A through F and T through Z or something on the first one, and then the mid-range on the second shard. So the balancer wouldn't actually be triggered in this case. It takes quite an imbalance to trigger the balancer, because in a real production system, you don't really want data to be sort of flying back and forth between shards, because balancing is not a lightweight operation. It takes time and resources to balance. So we really want to minimize the amount of data that has to be transferred, which is part of choosing a good shard key. You know, migrates are going to happen, but we want to minimize the amount that they do. So you actually need like, I think 8 or 9 chunks to trigger a balance. And this is actually kind of a problem, especially when we first released it and we had this 200 megabyte chunk size. You know, it takes like 2 gigs of data, which is a surprisingly large amount of data to trigger your first balancing. And so people would want to see their data moving around, but it wouldn't, and they'd be like, sharding's broken. So we ended up actually adding an option just to make people sort of happier and more satisfied, where you could set chunk size to 1, And so that way, if you're just playing with it, you can set it to 1 megabyte. You insert a couple documents, and you can start seeing your data flying around. And you can be like, OK, I see, this is working. But in production, you can use the big chunk size, and it won't have such a detrimental effect to your application, because it will be moving things around all the time. OK, so using this, so if you have your shards set up, and they're doing their auto-balancing thing, when you do like a query or something, you just talk to the MongoOS as though it's a single server, and it will just pass your request along to whatever shard or shards has the correct chunks to match that query. If it contains the shard key, it can target the right chunks. If it does not, it has to spew it out to all the chunks, all the shards. So it's worth remembering to try to choose a shard key where you'll be able to do targeted queries. I mean, you can do some, but as your system gets bigger, you want to minimize those. And then these shards are really just single MongoDB servers. So the MongoDB server executes the query like a normal MongoDB server, and then it returns the response to the MongoOS. And the MongoDB server has like no idea it's a shard. It just thinks it's a server, and the MongoOS just looks like a client to it. So the client issued it a query, it did the query, and it returns the result. And then the MongoOS forwards that along to the user. And then if it has to send it to all the shards, it does that, and it collects back the query results from the shards and forwards it along to the client. So, and the cool thing here is that you can actually do sorting across your entire cluster, because it'll send out the query with like sort on whatever to each shard, and so the shards return sorted results, and then the MongoOS can do like a merge sort of those sorted results and stream it back to the client, and so you can actually get a sorted answer from all of your shards. Then inserts, writes, MongoOS just looks at the shard key and sticks it in the appropriate shard. And so at the beginning we saw that we have this one layer of abstraction where you and your application think of the cluster as a single machine, and then there's a second layer here to be aware of, is that MongoOS thinks of each shard as a single machine, but really it should be probably a replica set, or it could be a master-slave configuration. As of the latest release, we do have a single server durability, so you could run it as a single server, but it's not a great idea, because then if that shard goes down, you won't be able to, you'll get partial query results if something had to hit it, or you won't be able to insert things that would go into a chunk that would be on that server if it goes down. So it's good to have redundancy. Especially if you're setting up a cluster, you probably should have enough machines around. You can set up like a replica set. And then it's worth mentioning, a lot of times, these diagrams only show one MongoOS. You can have, they're all stateless. Well, they don't persistently hold any data. They're very lightweight. We're just putting them on your application server, and then you've got this really short hop from application server to MongoOS, and then the MongoOS can go over the network and talk to your shards. I think there's actually, unfortunately, a bug where the MongoOS can't use domain sockets yet, Unix domain sockets, but when that is fixed, it should be a very, very short hop from application server through Unix domain socket to MongoOS. So that'll be nice, but probably not till like 1.8.1 or something. So it's important to remember that chunks aren't real. Like, chunks are something that are kept track of by the overall configuration of the cluster, but to the individual shards, all they see is a collection, and that collection contains multiple chunks to the MongoOS, but to the shard itself, it looks like it's just a collection. It has no idea about chunks or whatever. And this is an approximation. It actually sort of knows that there are chunks, but it's very difficult for it to get kind of statistics on a per chunk basis because it just sees a normal Mongo collection. It's just a normal MongoD holding some data. Which brings me to shards are just normal MongoDs. They just are holding and serving data like a normal MongoD. So you can use them, monitor them, log into one, and interact with it in the exact same way. OK, so moving on to the real point of this talk is the internals of all this. It doesn't persist anything, but it has a copy of the current configuration in memory. So how does it know what the current configuration is and that it's up to date and everything? I saw someone asking about config servers fly by. So this is where the config servers come in. They sort of hold all of the metadata about the cluster. The config servers are, they hold what shards are in the cluster, what chunks are in each shard, like every change that's happened in this cluster. It's also sort of a lock server. Like any member of the cluster can be like, I need a lock on some sort of process, and it'll lock down for the cluster for whatever operation they need to do that's sort of cluster-wide. So the MongoOS queries the config server and gets all this information about the cluster, at which point it knows where to query for things. And the config server also tells it a version number. And if you are familiar with Mongo sharding and you've seen config.version, this is not the same version number. Config.version is just sort of a API number for what sharding release you're using. I think pre-1.6 it was sharding version 1, and 1.6 was 2 maybe, and now it's 3. So that's not this. This is much more dynamic. It's like what is the state of the cluster at the moment. So we're at version 1 right now. And so the MongoOS is like, okay, I'm at version 1. I know about this shard with this chunk on it. We'll represent the chunk as a white box. And so it needs to be able to keep track of whether it's up to date or not. And one of the ways it keeps track of this is we version the chunks so it can figure out, and I'll get into how this keeps track of if it's up to date, but a chunk is given sort of an identifier of a major and a minor version. So this would be a chunk with a major version of 1 and minor version of 1 to start out with. And so let's say this chunk is getting big, and the MongoOS has been doing a bunch of inserts, and so the MongoOS is like, okay, it's time to turn this into 2 chunks because it's too big for 1 chunk. And so at that point, it'll split it into 2 chunks, and it'll increment the minor version. And so the MongoOS can still query this and everything because the major version is the same. And if we continue inserting data, say chunk 1.2 gets bigger, then that'll be split into 1.2 and 1.3. And one thing when I first learned about this, I was like, well, okay, what if chunk 1.1 gets bigger again? Chunk 1.2 has already been taken. So the chart actually does keep track of what the maximum minor version it has is, and so whenever a new chunk is created, it'll just increment that by 1, so we'll end up with chunk 1.4 as our new chunk. So how migrations work is we have a shard, and we want to move a chunk from this shard to another shard, say starting at shard 1, moving to shard 2. So shard 1 starts copying data to shard 2. And it does this very slowly, and there are all sorts of complications here. This would really work best if we could lock down the whole cluster at this point and not let anyone do anything, because that would just be a lot simpler. But people want to actually access and modify data, and we want this to be invisible to the user, so we have to let them do that while this chunk is migrating. So we're gradually transferring this data over. And remember that both of these shards are just normal MongoDBs, so basically now we've got the same data in 2 places on 2 different MongoDBs. Now, the MongoOS knows that shard 1 has the canonical version still. Shard 2 is very incomplete at the moment, so it'll be routing all the queries and inserts and whatever correctly. But imagine if you do like a count or something. The way Mongo does count is it's going to send it to MongoOS, and MongoOS is going to send the count command out to all the shards, and they're all going to execute the count command. And so some of this data is going to end up being counted twice. So a lot of people set up a sharded cluster, and they'll be like, you know, I'm doing counts, and I'm getting these wildly varying different things as things migrate. And I think this was fixed for 1.8, but I'm not sure. But it is in progress to actually take this into account and you know, fix the count. But you can get some weird answers for that. And that's one of the kind of leaks in the abstractions. So besides the whole like duplicate data kind of problem here, chunk moving is a really slow business. You have to take whatever data is in this chunk, and if it's on disk, you load it into memory, and then you have to transfer it across the wire, so it's network traffic, and then you have to do an insert on the other side. So it can take a while. It times out after a day, and it won't try to do it if your system seems really busy. It should probably take like 10 minutes, because it tries not to overload the system. The thing is, like sometimes people wait until their system is running like just at the edge, and they might not even know that it's running like just at the edge of its ability, and then they'll add a new shard, and it can be kind of disastrous because they've just suddenly overload their system. If it tries to move anything over, they'll have problems. So we advise like adding new shards early if possible, because it's much more convenient if your system has some room to maneuver, and it can use its resources to move chunks onto the new shard, because moving data around is always expensive. And also remember that this is happening on a live system. In reality, you'd probably have multiple chunks on this shard that were also being queried, and there would be queries and inserts and updates and everything coming in for both shards. So once you've got the full amount of data, then you're making sort of a global change here. You know, you're moving data from one shard to another. For the splits, it didn't really make much of a difference because it's the same data on the same shard, but here now we have to make sure that MongoOSs are going to route queries correctly in the new shard. So this is actually the one point where it has to lock down, and it contacts the config server and says, okay, we need to confirm this migrate with you, because the config server is sort of the definitive source of all information about the cluster. It has to sign off on any changes to it. So the config server, if it's cool with the change, it'll issue a new version number, and this is like kind of the global version number. We start with 1, now it's 2. And so that will say, okay, this chunk is now 2, and so we increment the major version number of the moved chunk, the previous shard, and now we can previous. And so now if chunk 1 gets big again, it can split, and chunk 2 can get bigger and split off and have many baby chunks on shard 2. So what happens if we finish this chunk migrate and we check in with the config servers and they don't sign off on it? We might not be able to reach them, or one of the config servers might be down, and you can't make any changes to the configuration if one server is down or 2 servers are down. So in that case, we can't make any changes. So we say, okay, never mind then, and we delete the chunk. There's nothing else we can do, and it's sort of a waste to do this. So it's good to keep your config servers up, but sometimes it's inevitable. And so if you when you're using sharding, you can see sort of an overview of what's going on with print sharding status. And if you use this command, you can kind of see this for each chunk. You've got a T and an I for it. And this T and I are the major and minor versions of the chunk. And so it was actually, T and I are a timestamp type that's a built-in type for Mongo. And it's just a type with two fields, timestamp and increment. And it's not really a timestamp, it's a major version. But we had the type from replication that had, two fields. So it's displayed a little weird because it's in units of 1,000 because timestamp is in seconds, and then the JavaScript shell displays seconds as milliseconds. So you end up with, 1,000, 2,000, 3,000. But other than that, that's your major. And if you're curious about this stuff, there's a changelog collection in your config server. If you use the config database and look at the changelog, you can see every split and migrate that's happened in your system and kind of follow through and see exactly what's been going on. Okay, so one thing is this system is live while the chunks are moving. If we're moving the chunk from one server to another and say we move over underscore ID field of 1. But now MongoS issues remove, so remove underscore ID of 1. And I mean, people are still querying this chunk, and we need to make it consistent and accurate. But we could be, so we need to apply it on this first shard, and we also need to make sure it's applied on the second shard, but we can't apply it now because we don't know if this hasn't been copied over yet. If we didn't have underscore ID of 1 and we removed it, and then we could end up with this weird inconsistent state on shard 2. If we try to apply these operations as we were moving data over, it might be applying operations to data we hadn't actually moved yet. So what we do is we create like another changelog with all the deletes that have happened and all of the changes that have happened, and basically the underscore IDs of all these documents that are basically the you're going to need to recopy this at the end list. And then when we're done and we've got a full copy of this chunk over on the second shard, we can apply all these changes, and we'll have a consistent view on both shards, and then delete the old chunk. So Fireandforget writes have had mixed reactions in the community, and they certainly made sharding a lot harder to do. What would be really handy here is to be able to say, like, have MongoS know when it's out of date. So it tries to do a write, say, on shard 1, and then it would be great if shard 1 could say, oh, nope, you said that you wanted to do this, but you actually have an out-of-date config. You need to talk to shard 2 about this document. However, we have these, and then so MongoS would go to the config server, get the updated configuration, and then it could query the correct shard. However, we have this Fireandforget write thing, so we can't depend on MongoS getting a response back. It could go for hundreds of operations or hours or days without ever getting a response back from MongoD. So like MongoD would be sitting there being like, I don't actually own this information. Like, you're sending it to the wrong place, but it wouldn't have any way of communicating that. So like, I guess like it could theoretically like forward this to shard 2 or something, but then suppose another migrate happened and the chunk had moved to shard 3, and so that you'd have this stupid like chain of sending this insert along. So we didn't want to do that, but we have no way of getting this information back as it was programmed. So what we do is we set up a write back listener. You might have seen this in the logs if you've run sharding. It's this special connection that just stays open between the MongoS and the shard, and it listens for MongoS being out-of-date errors. And if any of those are detected, it'll send back an error right away to the MongoS, and the MongoS will be like, whoa, I'm out of date. oh, stop sending things. And then it can contact the config server, and the shard will do a very limited, okay, I'll pass along this insert, but stop sending me inserts after this. And then it can start doing the inserts on the correct shard. And so one of these write-back listeners is created for every MongoS and every shard, so that they can keep track and make sure that the MongoS is actually up to date. So config servers are really important, and they're kind of interesting to check out. If you're interested in sharding, you can use the config database and look through all their collections, and it's got tons of information about your cluster in there. You can either have 1 or 3 config servers. We strongly recommend 3. 1 config server is good, like if you just want to try out a cluster. So you can't have 2 because that's just not fault tolerant enough. And the semantics between them are kind of complicated, so we don't want to support more than 3 yet, but we probably will in the future. It just hasn't really been a priority. But the interesting thing, actually, I think about config servers is we don't let you do transactions, but the config servers actually between themselves do. They use two-phase commit, and they do very limited transactions to make sure that their data is kept exactly in sync. And one thing to note is they're not like replica sets or anything. Don't set them up with replication. They have their own talk to each other, oddly enough. They go through the shards to talk to each other. So anyway, you've got these 3 config servers which are sort of linked. They all have exactly the same data. And if one goes down, you can't change anything about the configuration. It becomes read-only. They all have to be reachable to make any changes. That means no migrates, no adding any shards, no removing shards, and you can't start up any new MongoS's. MongoS's have to be able to reach all the config servers to start up. If all of them go down, that means your MongoS's can't update their configs. If they're out of date, they're just kind of stuck. And you really don't want to be in this situation. If you're in a read-only situation with 1 or 2 config servers down, that can persist for a while. You know, it's just, if you chose a good shard key and your data is not going to go out of whack without constant migrates, you can put up with a read-only config server set up for probably days or maybe weeks. Because you shouldn't need to do migrates constantly. But you do want, generally, all of them to be up. And then, finally, the balancer. So, the balancer is like just all of the MongoS's every couple minutes are like, hey, I want to do a balancing round. And so the config server, in its lock server capacity, issues a balancer lock to whoever gets there first. And then any other MongoS's there trying to do a balancing round have to try again later. And so once a MongoS has been accepted as a balancer, it can decide to move things around in the cluster. And then once it's done, the balancing lock is released, and in a couple minutes someone else can become a balancer. So hopefully this has given you kind of an overview of how sharding is set up, why it was set up this way. I hope it's made sort of the inner workings a bit clearer for people. If you're interested in a more practical, like how this can actually be used in your application, this is the new ebook, Scaling MongoDB, and it goes through, you know, how to set it up, how to choose a shard key, how to administrate it, how to fix things that go wrong, and yeah, it should be good. I hope you guys enjoyed this, and now I guess I'll take some questions. Okay, let's see.
Hi, Kristina. I think we're having a little bit of latency, so I think you should read the questions and answer them. So I'll just make, they're in chronological order there.
Okay. Let's see. So C. Moyer asks, should we think of shard keys like indexes in a standard database? And they do have similarities. I mean, you actually have to have an index on a shard key, and it is a way that the data is organized. I mean, it's not identical to an index, but a lot of the same considerations hold for it. Yeah, if you're choosing a shard key, you should really read up on the MongoDB.org wiki. It's got a nice guide on it. Seymour asks, can we schedule balancing to only happen on off-peak hours? No, you can't. The balancer does try to avoid balancing on peak hours. Oh, right, off-peak. So the balancer tries to avoid doing it, but you can actually turn off the balancer if you want, and then you could just turn it on off-peak hours, I suppose, but that's a little weird. I haven't heard of people doing that, but I suppose you could try it. Let us know how it goes. Matt Towers asks where the docs are on selecting an appropriate shard key. And those are on the MongoDB.org wiki. You can search for how to choose a shard key, I think. And let's see. Tim Lindquist asks, can you configure the chunk size and/or data size to trigger balancing? And you can configure chunk size. There's a -- chunk size parameter that you can start MongoS with, and you can change it in the config servers. But I'd really recommend going with Mongo's default size. Usually people who are trying to tweak the chunk size are trying to fix something, and changing the chunk size isn't actually going to fix it. So it's better to figure out what the actual thing is you're trying to do and fix that instead. If you're having problems with it not balancing enough, it might be like the shard key needs to be fixed or something, or I don't know. But usually chunk size is not the culprit there. Ronaldo Giudici asks, how do we know that we're running at the edge of a system? How do we know that our system is not able to add another shard without overloading it? So in the system, I mean, I'd say check out the monitoring pages. There are several threads on the mailing list about how to know when you've reached capacity. There are a bunch of monitoring tools. I mean, we just came out, I think, with Chrome extension, which is kind of cool, and it graphs all the Mongo stats real time. I think it's called Mongo Live. But it's sort of a per system thing. Robert Lucen asks, how are the concepts you mentioned related to standard RDBMS issues of ACID and read consistency? I mean, you know, MongoDB isn't ACID because it doesn't have transactions, well, not that you can see, and it is consistent. I mean, we jump through hoops here to make it consistent through thick and thin. So you'll always get a consistent answer, except when distributed systems say you can't get a consistent answer, in which case we punt on that because, sorry, you know, that's the laws of physics, or computing or whatever. You know, some things are just not possible when you have your data spread out across multiple machines. We can't lock down all of the machines and check for a certain set of properties, which is one of the reasons we don't support arbitrary user transactions, because we can't lock down everything and make sure everything happened across all these machines in any sort of efficient way. But for you know, updates, reads, inserts, whatever, we are as careful as possible that you are going to get consistent results. So Matt Towers asks, was waiting too long to move shards the problem that Foursquare ran into? I think so. I don't remember. There's a whole write-up we did that goes into that. I think that was the problem. They were sort of just on the edge, and they added a new shard, and it sort of tipped them over. But I don't take my word for it. Michael Ritchie asks, why do you have multiple MongoS's? You can have multiple MongoS's just for greater throughput. You know, there's a limit to how much a single server can put out there. If you have multiple application servers, they can all be going full blast at their individual MongoS's. It's also good because that way you can have backup MongoS's if one goes down. They're completely don't persist anything, as I mentioned. So you can just start using another one. You can bring up ones whenever you want, and they'll automatically sync from the config servers, figure out what's going on, and it's just a fault tolerance kind of thing. Having multiple processes for any part of the system is good. Tim Lindquist asks recommendations of backing up data. Is replication still preferred for handling failover? Yeah, so backing up a cluster is a really difficult proposition because really, even if you could lock down the whole cluster, take a snapshot, are you really going to restore a single node of the cluster? But then you've got a problem like, what if you took a backup of that node and then someone migrated data into that node and then it goes down, and then you restore from the backup, but you're missing the data that was migrated in post-backup. So it's a tricky problem. If you take regular backups, you can kind of smush them together maybe and get a consistent thing. But generally, we do highly recommend replication because keeping something up at all times for a shard is a good way to keep you from having to do this weird mashup backup thing. Can I talk? Okay, so Michael Ritchie also asks, can you talk about replication and sharding? So each shard can be a master-slave configuration or a replica set. I actually realized the other day that you might be able to actually make a sharded cluster as a shard. Have the MongoS be your shard. I'm not sure if that would work, and I highly don't recommend it at all. But it would be kind of funny to try. So you just add a replica set. That's really the recommended thing, because then you get the nice automatic failover, and MongoS can keep using that node for reads, that shard for reads and writes if the master goes down. But you basically just send it the set name / and then some hosts when you add the shard. Let's see, we got another question about backups, so I'm going to skip that. And then, are there a lot of queries that cross shards? If there are a lot of queries that cross shards, can you change the shard key dynamically? No, you can't. Right now, it's kind of a pain to change the shard key. And so one of the things we recommend is don't start with sharding. If you can avoid it, start with a single node. Figure out what kind of your access patterns are, what a good shard key would be based on how your application is being accessed, and then choose a shard key based on that. And you can shard out from a replica set or master-slave setup with no downtime. So you might as well start with a replica set or master-slave and then move to a cluster when you need to. Let's see. Justin Deering asks, can you make your shard members masters and have a slave for each of them? I mean, each shard can have a master and a slave. Yeah, I mean, I'm not sure if you're asking about master-slave or just making the master the shard and having a slave that isn't part of the shard, which I suppose would work, but then MongoS can distribute reads to the slaves if you want, so then you're kind of losing that ability if you didn't have the slave as part of the shard. And then Suvere, it looks like, has clarified that his question was about taking backup by fsync. And yes, if you're taking backups by node, then you totally can do the fsync and lock thing and take a dump of it. That would work fine. They're, as I mentioned, they're just normal MongoDBs. Anything you can do with a replica set, you can do with a shard. So, if it's a replica set, obviously. Okay, so, and that looks like. Oh, are there minimum configurations? I.e., can you have multiple shards with slaves on one machine? Oh, minimum configuration. Can you have a bunch of shards and slaves on one machine? Yes, you totally can. And to try it out or whatever, that's totally fine. Generally, the reasons that people shard out, to get more RAM, to store more data, in real life, these reasons mean that it isn't very, it doesn't really make sense to do it all on one machine. But if you're trying it out, totally, you can run 3 config servers, 5 replica sets, and 10 MongoS's all on one machine. So, yeah, and you can. You definitely don't have to have a separate machine for every single piece of this process. Like, it looks very intimidating with all the MongoS's and the config servers and the shards. They're each replica sets. But, yeah, you can double things up on different machines. Config servers take very little disk space or processing power or anything. There may be a gig of data if it's huge, but it's unlikely. So, you can put those anywhere. You put the MongoS's on your app servers, and then you can do whatever you want with your shard configurations. Okay, so are there recommended examples of recommended configurations? There's one on the wiki for like sharding introduction or something, and it shows like a sample configuration on like a certain number of machines and doubling up different processes on different machines. So you can check that out. I don't know of any other samples. And I guess that's it.
Hey, thanks, Kristina. Catherine here. You certainly know your stuff. There's no question about that. It was extremely impressive. So thank you very much. I was blown away by the way you answered all those questions. So thank you very much. And you guys, if you want to follow Kristina on Twitter, again, is it K Chodorow? Or
yes. Yeah, I'll put in the chat again.
Okay, great. Great. And you guys be sure, thanks. And what's that question from Adam? You're trying to get my head around. Do you want to answer that quickly? Okay.
Yeah, sure. Just with replica sets, you can sync and lock the slave so it flushes the data on the slave to disk and then locks it against further writes. And then you can take a dump of the data or file system snapshot of that slave because it's in a consistent state on disk. And then, that becomes your backup. So you can do that for each shard, say. Okay. That's
okay. All right, I think we should call it a day now. Thanks, Kristina. And you cover all of this in your new publication, right? Your new ebook.
Well, this is more like internal stuff. Like the book is more practical, actually setting it up and using it. So.
Okay. Okay. This is how it works. All right. Well.
Yeah.
Great, everyone. So thanks to the audience. We had a very knowledgeable audience today, which I always love. So I just want to thank everyone and join us again next time. All right. Bye-bye.
Bye.